Now we are going to discuss the third topic under Introduction to Inventory and Inventory and Materials Management. So during in this topic we will be referring to two important issues. One is the classes of inventory problems. In the last interaction we have already identified the factors related to inventory problem, the classification, and you have already come to know that how these classes are made, and so there are different types of inventory problems. Now what is important is that you must have a very clear-cut idea, and you must start thinking simply about the inventory problems. So now the classes of we must conclude something solidly about the classes of inventory problems. So the first thing we should do, and the second one, that is the next issue we are going to discuss, that is the inventory related costs. Usually what happens that any inventory related problem you formulate, and obviously during the formulation you come to know what are the decision variables, and you need to determine the values of these decision variables under constraints or under certain conditions, under certain assumptions, in such a way that you get the best possible performance. Now related to the inventory, how do you assess its inventory management systems, any type of inventory management systems? So how do you assess its the performance? That means what are the the performance related the criteria with which you judge the efficiency, effectiveness, or the quality of an inventory control system. So here your main objective is you will run an inventory control systems meeting all the objectives in such a way that the cost of running the inventory control system is minimum. So and when you try to determine the values of the decision variables in such a way that the total relevant cost of inventory or the running the inventory systems is held at minimum, then we say that this is I have optimally determined the values of the decision variables, when to order and how much to order. So these are the two important decision variables in any kind of inventory problem. So now let us conclude about the classification of inventory problem. This is an important topic. So what we have concluded that each class of inventory problem is represented by a root as depicted in the figure. We have already seen the figures, in fact, where all sorts of the roots are depicted, and on the root you will find you come across several types of factors under the different levels or the different types. So so how many such roots you have come across? So that many inventory control problems you have to deal with. So at one extreme you have the most simple problem, at other extreme you have the most complex problem. So in the simplest form, now there must be some extraction out of it. So what is it? That means I am going to represent the classification of inventory problems with a simple in a table format. So the inventory problems can be classified as per the following. First, what you say, that the type of problem. Forget about the lead time. So lead time also need to be considered, but here only the two factors I have considered. Okay, these two factors actually they are at the heart of the problem. First one is the type of problems, either it is could be the static problem, one time decision, or the dynamic inventory problems. That means is the multi decisions, so the multiple time periods you have to take, the multiple decisions. Then this supply is must meet the demand. That is the condition you have to create. So now the demand may be known with certainty. That is one case. The demand may be known with risk. That means related to the demand, you have you know what is this demand distribution, but exact demand is not known. And whereas in this is the demand, that means the problem under uncertainty. That means demand is known with uncertainty. That means even the demand distribution is not known. So obviously, you know, no demand distribution known doesn't mean there is no information related to the demand. If it is a no information case, nothing is known about the demand, obviously there cannot be any problem formulation. So in majority of, only in the rarest of the rare cases, right, what you will find that I am not getting any idea about the demand level. But barring those the few cases, this is rarely they do happen, you will find in majority of the cases, even if you do not know the distribution of the demand, at least some information you have. So sometimes what we say that this problem is referred to as the distribution free analysis. Okay, so even if the distribution is not known, in the probability theory, there are certain you know the inequality expressions we may use, even if for the given decision the variable, or say decision variable, where for the demand, particularly in this case, or say the random variable. So even those particular the expressions, inequality expressions, are valid, and for any type of distribution. So you can conveniently use those the inequality expressions to formulate the problem, and then you get the expressions of the decision variable. So it cannot be the no information case. No information means no problem formulation and no solution. So it's a partial information. Along with, you know, and whenever you have the partial information about the demand, you must opt for the techniques. Those are referred to as the distribution free analysis. So now these combinations are commonly you come across. First one is the demand is known with certainty, and you know the problem is static inventory problem. So this is this problem is absolutely there is no problem at all. Everything is known. So this particular cell is not coming under the inventory control domain. If at all it is a problem, now this problem means the demand is not with certainty, and it is a static inventory problem. That means just one order you have to place. So the number of orders that is known, as well as the order quantity also will be known, and when to place the order, that is also known. So if at all it is a problem, this is coming under actually the scheduling problem, and when you deal with multiple items, is it okay? Now this is this problem we will be dealing with. That means the demand is known with risk, demand distribution is known, whereas the order quantity, just the number of orders is just one, or the number of orders could be greater than one. Demand is known with the risk. Similarly, when the demand is known with uncertainty, both the static as well as the dynamic cases we must be dealing with. So there are 6 classes of problems. Okay, we refer to this table. However, the static inventory problem under certainty, this point already I have elaborated, does not come under inventory problem, as 2 decisions when to order and how much to order how much to order can be made without even formulating the problem. So that point is to be noted. The decisions are already known. Only when a number of items are considered under this class, means more number of items, so more than one items you consider, the problem may refer to a typical scheduling problem. So this point already I have mentioned. Now let us talk about the inventory related costs. This is a very important the issue, because while you formulate the problem, while you try to determine the optimal values of the decision variables, so your objective is to, in majority of the cases, the minimization of the total relevant cost. And this when you write down the total relevant cost expression, you need to know actually what are the different types of costs applicable in a typical inventory control system. Okay. So while formulating any class of problem, we need to know the working of the inventory control systems. How does it work? Suppose I say there is a perpetual inventory system. So the first thing you must know that how does it work. And many a time we add one more thing, that is I need to explain my inventory control problem related to a particular item. So the first thing I must do, that I must be able to draw an inventory profile, the diagram. And when I will draw this diagram, the inventory profile, okay, as per a particular inventory control problem. So when I look at the inventory profile, so I'll get an idea that what kind of the problem I must deal with. Is it okay? So this is this way we should proceed. That means you have to explain the problem in a systematic manner, so that the problem problem quality as well as the intricacies involved in getting a solution of a problem, whether it's a simple problem or complex problems, are you should be aware of. Is it okay? How difficult the problem is. By just looking at the inventory, the profile, you should come to know. So then only we'll conclude that you have sufficient expertise and knowledge in this particular area. So we need to know the working of the inventory control system. This is a must. This is a necessary condition. Its parameters, the constraints, if any, and assumptions for modeling. Okay, so these are the issues. You please note them down, and later on when you go for modeling, you will be referring to different kinds of parameters, different kinds of control systems, different kinds of constraints, etc., etc. Usually the values of these parameters are determined such that the cost of the inventory control system under consideration is held at a minimum level. Is it okay? So usually the parameters of an inventory control, so please note it down. When suppose any inventory control system I explain against a particular item, immediately you must be able to identify that what are the parameters of these inventory control systems. Like for example, when we refer to the perpetual inventory control system for a single item, there are two parameters we have. One is the reorder point, and the second one is the order quantity. When we refer to periodic inventory control systems, we have again two parameters. What is the maximum inventory, and what is the order period. Is it okay? So the order period remains fixed. Okay, so in the periodic review control systems. So similarly for all other inventory control systems, so we refer to their parameters. Usually the values of these parameters are determined such that the cost of the inventory control systems under consideration is held at a minimum level. So everything you determine in such a way, the total cost of running the system is held at a minimum. So in this context, the types of inventory related costs are to be identified. So this is so you will come to know what are the relevant the cost elements or the types of costs. There are a number of inventory related costs that need to be considered. Okay. Now I will just explain briefly that what are these costs. Now these costs are as follows. The first one is the purchase cost. Now what is this purchase cost? This is also known as the procurement cost. So when you try to procure say certain one item from a supplier, so a deal is made, the order is released and to the supplier, and in course of time this item will be supplied. So this when the agreement is made, when the purchase order is placed, that means the purchase prices will be known. Is it okay? And at that purchase price will be charged against say as per the agreement and all. So this is basically a procurement cost. While an item is purchased from an outside source of the supplier, as I have been telling you, unit purchase price for the item determines the purchase cost. That means the total purchase cost will be the unit purchase price multiplied by the number of units purchased, okay, for a given period of time. Then the next one is the setup cost. That means many a time you go for self-supplying. You need this item at the fabrication shop. Now what do? You place an work order, not the purchase order, work order to the machine shop, and as per your requirements they will be producing that particular item or the part, and subsequently when the part is manufactured, that the finished part will be sent to you at the fabrication shop. So this is a typical self-supply or the inside supply case. So this cost is relevant, that means the setup cost. When the item is supplied from within the plant, the cost associated with setting up of the process or the machinery. So there is a setup time. You need to produce say 500 units at a particular machine, and these 500 units I will be producing at a particular machine, and I will be sending it to the fabrication shop. Now these 500, in order to produce 500 units, I need to have just one setup, and that means I have to have this setup. For that certain activities you have to carry out, and any activity you carry out there is a cost associated with it. So related to setup there must be a cost associated with it, because setup is an activity. So that's why it is referred to as the setup cost. So the cost associated with setting up of the process or the machinery as per production run, that is very important, and the lot size is the setup cost. So you need to estimate the setup cost. It is usually measured per setup basis. Okay. Now there is also a cost we should be bothering about, that is the production cost. This is incurred when the item in required quantity is produced by the production department. Is it okay? So that is basically the self-supply case. First you get the setup and then you start producing it. Is it okay? The production cost per unit is its measures. So many a time while you formulate that your problem, and the total cost expression is to be known, so you need to refer to the production cost. Then you have the ordering cost or the order cost. So what is this? This cost is relevant when the item is supplied from outside. Okay, so outside supply case. An authorization note in the form of purchase order. Is it okay? It's a legal document. In fact, the purchase order is to be placed to the supplier. The cost of preparing and placing the order for the item in required quantity and quality under agreed terms and conditions is referred to as the ordering cost. Right. So you need to know what are the activities you carry out while you place the order, while you make the order, while you prepare the order, what you can say, the purchase order. There are many sorts of activities you carry out, and then when you get the order supplied, then also many sorts of activities you carry out. So all the activities is to be noted down, and then the corresponding the cost estimates you must have, and this exercise you follow rigorously, and you will get an estimate with minimum error of the ordering cost, and usually it is measured per order basis. That means ordering cost per order. So one particular order, that means the purchase order, it may just consider one item or multiple items. That means there are cases where one item, for each item you need to have one supplier. For many items you can have one supplier. That means the same supplier is supplying not only one item but several items. So obviously, if for such a supplier, it is most likely that you will include not only say the one item in the purchase order but the multiple items, and these multiple items have this, with respect to all these items, you must have the same terms and conditions as agreed upon. Okay, so these are the finer details. Later on, when we'll refer to the purchasing procedures, purchasing systems, many of such issues we'll be discussing. Now, there's an important or very important cost element we have, that is referred to as the inventory carrying or the holding cost. Now, this is essentially the cost of money tied up in inventory. As I've already mentioned, that the inventory means basically the tied up capital. Is it okay? So your inventory system should be such that the minimum amount of the capital is tied up in inventory. That is to be ensured. And if suppose in certain cases, suppose you find that it is too high, that means the amount of money or amount of capital tied up in inventory as idle resource is very high. So what you need to do, it will directly affect your operational performance. That means at the right point in time, you will not get the right quantity of materials. This is going to happen. That means the flow will be disturbed. So what you need to do, you need to improve your inventory control systems in such a way that the enough amount of capital is released for other purposes from the inventory. That means in plain and simple terms, it means that inventory investment to be assessed at any point in time, and you must use various means to release capital from this idle resource in such a way that in next planning horizon, the inventory investment is substantially reduced. There is a time lag between the arrival or the production of inventory and its use. While it is stored for the time period, it is essential that it is kept in good condition. It's clearly understood. The cost associated with the lost earning power due to cost of the money tied up in inventory, without getting the return if this tied up money were invested elsewhere. Obviously, this is the inventory, huge amount of inventory, idle resource. So the capital is tied up, money is tied up. So unless you release it, how can you use this money for some other purposes, for productive purposes? So what do you need to do? That means you keep the item, okay, till it is used in acceptable good condition. So you need to look into the storage cost, you need to look into the deterioration cost, what sort of insurance the premium you provide or you need to bear, and other prevention measures taken to maintain inventory of the item in acceptable and usable condition. I keep the item, it will be used after say 1 month. Then make sure that you make sure that it is kept in such a condition that the value of the item, that means the economic value of the inventory, is not lost. So for that certain the cost you have to bear. So these cost elements you need to identify, these activities which you carry out to for upkeep and maintenance of the items in your stores. So these activities are to be identified, corresponding cost estimates you must be aware of, and then you get an idea about the estimate of inventory carrying or the holding cost. So this is an important cost. So this cost is measured either as a proportion or a percent of the cost of average inventory. Later on you will come to know that how to compute the average inventory cost. Okay, so normally the practice has been that I will estimate the inventory carrying cost as a percent or the proportion of the average inventory held, like say 15%, 20%, or say the 10% or 8%. So this way you specify the inventory carrying or the holding cost, or in absolute term you say that the price of the item is 10 rupees. Now I am just spending say 1 rupee for in relation to its carrying or holding in good condition. Is it okay? Per unit time, per year or per month. So that means essentially in absolute terms you are spending 1 rupee against the unit price of the item for inventory carrying or inventory holding. Okay, so this is the idea. Then you have two important cost elements: overstock cost. This cost is incurred when the supply is more than demand, and at the end of the selling season an extra amount of inventory beyond demand is kept. Is very clearly explained. Elimination or at least minimization of overstock amount is one of the main objectives of any inventory control system. Now if there is an overstock, there could be situations which is referred to as basically the understock cost situation, understock situation. So corresponding to occurrence of understock, there must be some understock cost, also referred to as out of stock or the stock out cost. This is incurred when supply is less than demand during a period of time. Okay, so depending on the response of the customers to unfulfilled demand. Is it okay? There may be two types of understock cost. Either it's a back ordering cost or the lost sales cost. Now what is the back ordering cost? In case unfulfilled demand remains and can be met later or the next time period. There are cases, that means the customers right now is not getting the item, but it can wait. It's not that it's waiting for the medicine or waiting for the food. Is it okay? It's a maybe any other item, so he can wait for next 15 days or 1 month even, or even 6 months. So you are unable to supply definitely this item on time, but the customer is ready to wait. So obviously there is a cost. You cannot avoid this cost. Maybe the customer is not that happy, but he is not leaving you. So if you face this sort of situation, this is referred to as the back ordering cost. In certain cases, the back ordering is well planned. Is it okay? For certain cases, later on we'll deal with this case, but otherwise in many cases the risk is the lost sales. That means in case unfulfilled demand is lost forever, he's asking for food, he's asking for medicine, and right now you don't have any stock. So can you hold him there? Can you say that why don't you come after 7 days? So obviously immediately he will go elsewhere. So for you, the demand is lost. isn't it? Forever in many cases. So this is the lost sales cost. So depending on the problem you face, both the types of costs you need to consider. So among these costs, the purchase cost is considered a fixed cost, obviously, as it remains same irrespective of the order quantity. And other types of costs as stated are considered a variable cost, as these costs are dependent on inventory control systems or policy. Is it okay? So while you write down the total cost expression, the first one is the fixed cost, and the next one is the variable cost. So if you change the inventory control system, usually the variable cost part may change. While formulating a problem, understock cost may be assumed to be a constant irrespective of amount of shortages. There are cases, that means the fixed out of stock cost. That means for all practical purposes, whether there is a shortages of 10 units or 100 units, the cost, the understock cost you bear, that remains same. But alternatively, it may be considered as a variable, that means per unit basis. So there is one very important cost element you should consider. This is called systemic or implementation cost, systemic cost. So an important type of cost called systemic cost, cost incurred for making changes in the system, needs to be considered when a new or better inventory control system is introduced for an item. So this part also will be taking up when you talk about the implementation cost of a new inventory control systems. So there must be some estimates of this, and then only you can compare between different alternatives for inventory control systems. So this is an example. So this is an inventory carrying cost. So here we can explain it later on also. So the inventory cost profile is like this. That means this is the cost, y-axis is the cost, and this is your raw material cost. This part is essentially it is the direct labor cost, and the BC is basically the factory overhead. Is it okay? So this is the throughput time from material acquisition to product shipment, and this is from the raw materials to the finished goods. That means this part is the WIP. Okay, so as the process as you have more number of processes, so this the labor cost increases, and this is the manufacturing cycle time from this point to this point. Okay, so thank you so much.